Hello, thank you very much for your interest in my poster, Record High Sea Surface Temperature in 2023. As we know that global averaged SST created near daily records in March 2023 and then again in April and August. The question is what caused the record high SST? We use the NOAA Daily Optimum Interpolation SST, that is GHRSST version 2.1, and monthly extended reconstructed SST version 5. It's called ERSST-V5, and demonstrated that the record high SST is associated with a long-term warming trend, a transition from tripod dip La Niña to 2023-2024 El Niño, and a shift to the warm phase of the multi-decadal Pacific Atlantic Arctic mode. We call this mode PAA mode. Figure 1a shows the globally averaged SST from 1982 to 2023, indicated by gray lines. Exceptions are that the SST in 2015, 2016, and 2023 are indicated by solid green, purple, and red line. We can see record high SSTs in August 2015, March 2016, April 2023, and August 2023. These high SSTs created record high SST anomaly. This can be seen in Figure 1a in reference to the climatology of 1982-2021 or in Figure 1b. It is very clear that SSTs are record high from March to December 2023. These record high SSTs and SSTs appeared in the North Pacific, Tropical Pacific, North Atlantic, Arctic, and the Southern Ocean from the March to December 2023. This is demonstrated in the examples of SSTs in the August 2023 in Figure 2a. The SSTs are above 2 degrees in the North Pacific, Tropical Pacific, North Atlantic, and Arctic, and above 1 degree in the Southern Ocean. The high SSTs and SSTs are concurred with marine heat waves as shown in Figure 2b in North Pacific, Tropical Pacific, North Atlantic, Arctic, and the Southern Ocean in unit of degree day. Marine heat waves are defined as SSTs above the 90th percentile. To demonstrate the extremeness of the record high SSTs in 2023, we define a supermarine heat wave that is measured by the SST difference from the maximum SST over 1982 to 2022. The supermarine heat wave can be seen in the North Pacific, Tropical Pacific, North Atlantic, Arctic, and the Southern Ocean as shown in Figure 2c. After demonstrating the record high SSTs in 2023, the question is what caused the record high SSTs? Figure 3a shows the long-term warming trend from 1982 to 2023. Warming is dominant over the global oceans, particularly in the North Pacific, Western Tropical Pacific, South Pacific, North and South Atlantic, Arctic coasts, and Indian Ocean. The globally averaged SSTA increased clearly as shown by the solid black line in Figure 3b. The role of the long-term warming is dominant. Since the SSTA becomes flat after removing the long-term warming trend, as indicated by the solid red line in Figure 3b. After removing the long-term warming trend in each grid point, we analyzed the UF1, UF2, and their associated PC1 and PC2. UF1 is a typical El Niño pattern as seen in Figure 3C, and PC1 has typical frequency of 3 to 7 years as seen in Figure 3D. This PC1 or Niño 3.4 index is well correlated with the trended SSTA as shown in Figure 2B, indicating the law of Ansel in the global average SST or SSTA. This explains why the 2023-2024 El Niño partially resulted in the record high SSTs in 2023. Now let's look at the UF2. UF2 has a clear loading in the North Pacific, North Atlantic, and Arctic, north of 30 degrees north, as seen in Figure 3E, and it varies at a time scale of 50 to 70 years, as seen in Figure 3F. We call this UF2 the Pacific Atlantic Arctic mode, or PAA mode. From the figure, we can see that PAA mode was in its warm phase after 2000 and was in its peak in 2023, particularly in the boreal summer. The peak PAA in 2023 is a clear indication of high SSTs in Pacific Atlantic Arctic sectors, north of 30 degrees north, particularly in the boreal summer. To demonstrate the existence of the PAA mode, we calculate the averaged SSTAs in the North Pacific, north of 30 degrees north, the North Atlantic between 30 degrees north and 60 degrees north, and the Arctic between 60 degrees north and 80 degrees north. These SSTAs can be seen by the solid black lines in Figure 4. After removing the long-term warming trend, the averaged SSTAs in these three regions clearly show a PAA mode. The SSTAs are relatively high from the 1950s to the 1960s, and from the 2010s and 2020s. And the SSTAs are relatively lower from 1970s to 2000s. After further removing the PAA mode, the averaged SSTAs in those regions become flat. This means that the SST variability is greatly reduced after removing long-term warming trend and the PAA mode. This indicates the important role of the warming trend and the PAA mode in the high-latitude SST. What we want to note is that the Ansel impact is small in the high-latitude SST. Finally, as an example, Figure 5a shows the SSTAs in August 2023. The SSTAs are high in the North Pacific, Eastern Tropical Pacific, North Atlantic, Arctic coasts, Indian Ocean, and part of the Southern Ocean. The SSTAs become weaker in the North Pacific, North Atlantic, Arctic coasts, Indian Ocean, and the Southern Ocean after removing the long-term trend in Figure 5b, and become further weak in the North Pacific, North Atlantic, Arctic coasts after removing the PAA mode in Figure 5c. The SST anomaly in the Eastern Tropical Pacific weakens after removing the Ansel mode in Figure 5d. These evidence have demonstrated that the long-term warming trend, warming phase of the Pacific Atlantic Arctic mode, and 2023-2024 El Niño are attributed to the record high SSTs in 2023. Thank you very much for your attention.